Welcome to a world powered by the wind. Wind energy, a cornerstone of renewable power, harnesses the natural force.
At the heart of this process stands the wind turbine, an elegant feat of engineering.
This rotational energy is then transferred down to the nacelle, the housing atop the tower, which is crucial. Within the nacelle, the gearbox dramatically increases the rotational speed, which is then fed into the generator. And below, the massive turbine foundation securely anchors this entire structure, ensuring wind turbine blades, though engineering marvels, face relentless structural challenges. Equally damaging is leading-edge erosion. Rain, dust, and hail hitting the blade at high speeds act like sandpaper.
Beyond internal fatigue, the leading edge of the blade faces constant assault from the
When degradation becomes too severe, these sections require costly repair or even full replacement, impacting operational efficiency.
Is extreme stress. Bearing failure is a particularly common issue, with internal wear and microfractures often developing silently until a catastrophic breakdown occurs.
This intricate system progressively amplifies rotational speed through multiple stages, a process vital for the turbine's efficiency.
While highly efficient, the gearbox operates under extreme stress, making it highly susceptible to wear and tear. Critical components like bearings are particularly vulnerable, with microscopic wear leading to macroscopic failures over time.
The immense forces generated within the gearbox create significant heat, leading to critical overheat.
Even the vital lubrication system can be compromised by debris, leading to increased friction, accelerated wear.
The gearbox, despite its critical role in power generation, remains one of the most complex and vulnerable systems. The nacelle houses the critical components, including the robust gearbox assembly. This cutaway view reveals the internal mechanisms. Note the stress fracture here, which is causing this critical overheating zones. This cutaway view reveals the gearbox and its lubrication system. Notice how the metallic debris causes contamination. Moving beyond the gearbox, we arrive at the generator, the true heart of power conversion, where mechanical energy, designed for high-efficiency generation, This complex machine is responsible for converting the mechanical energy. At its core, the generator consists of the stationary stator, filled with conductive windings. As electricity flows through these windings, heat is an inevitable byproduct. This relentless thermal stress can lead to insulation degradation over time, creating pathways for electrical. Beyond insulation failure, the generator faces a constant battle against overheating, which can. These internal inefficiencies manifest as fluctuating power output. Addressing these interwoven electrical and thermal challenges within the generator is crucial for maximizing energy production.
Transporting components like these massive rotor blades requires meticulous planning across vast distances and challenging terrain.
Moving these oversized components, like the nacelle itself, demands specialized heavy-lift vehicles and highly precise maneuvering. This extreme height and remote location underscore a significant problem. This necessitates highly specialized equipment and techniques for repairs, often involving robotic systems or advanced rope access.
While wind energy offers a clean power source, its broader ecological footprint and end-of-life challenges demand our attention.
The constant movement of the rotor blades also poses a threat to local wildlife, particularly birds and bats. This considerable land footprint, necessary for installation and transport, significantly alters the local ecology. Beyond the visible footprint, the true scale of infrastructure lies beneath. Each turbine And when a turbine reaches the end of its life, new challenges emerge. Its massive blades. Constructed from fiberglass and resin composites, these blades are incredibly difficult to recycle. Often, beyond material recovery, the physical footprint of wind farms demands extensive environmental restoration efforts. The ecological considerations extend far beyond power generation, impacting land use and local ecosystems for decades. This balance is not static. It requires continuous innovation and responsible planning throughout a wind. Only by embracing these challenges and striving for comprehensive sustainability can we truly integrate wind. To compensate, extensive and costly grid upgrades are often necessary. This involves building new
the initial investment required for substantial grid upgrade.
Beyond the initial grid infrastructure, the cost of manufacturing each turbine, alongside the continuous operation.
These economic realities, coupled with the immense infrastructure.
However, innovation is relentless, pushing us beyond these limitations towards a future where